I think it's awesome that you all came out to hear about MCP. I think we're at a really pivotal moment in the protocol, so it's a good time to have this conversation. By show of hands, how many people in the audience have a manager? Okay, most people. How many of you are a manager? Like you manage other people? A few. How many of you are a micromanager? So we all don't like micromanagers, right? I mean, there's a lot of problems with micromanagers, but actually for a manager to be a micromanager, I think that's an even bigger problem, right? It's hard to scale as a manager if you're a micromanager. And I think that in MCP, I would argue that the way we do tool calling today is kind of like the agent being a micromanager. The agent is gonna sit there and it's gonna watch what you're doing. It's gonna wait until you finish one task. It's gonna look at the result, and then it's gonna do something else. So this kind of paradigm has been bothering me for a while. Most of you were not at the San Francisco Summit, but I was ranting about it at the San Francisco Summit. And it's taken us a while to think about how to solve this problem. What is the right way to solve this problem? And we started kind of talking with people that are using MCP and trying to understand, were they running into this problem? How are they running into this problem? And a couple of the big companies that I spoke with, big healthcare companies, they were actually using MCP for molecular analysis. So they had these long-running molecular analyses that would run 30, 60 minutes, maybe more. And they were trying to fit that in a synchronous tool call, right? So they were literally kept a connection open, waiting for a multi-hour molecular analysis. I mean, that's crazy. You would never do that in traditional software engineering. So obviously they ran into a bunch of pitfalls. We spoke with a bunch of other companies that were doing standard enterprise automation, like SDLC stuff. And they had long duration, long running workflows, and same kind of thing, right? They're just running into challenges. And they sort of said to us hey, we would love a way to manage this as an asynchronous process. We would love it if we could kick off this workflow and let our agent continue doing other stuff and then come back at a later point and see the result of that workflow. Same thing with code migration. So internally at Amazon, we were building agents for code migration that would just automatically migrate code. And again, code migration can be a long-running process, and they just kept running into challenges. Now, this team who was actually working on code migration, they said, hey, we're gonna solve this problem. So they actually implemented a workaround. They created 3 tools. One tool starts an asynchronous job. Another tool gets the status of the job. They poll on that. And the final tool gets the final result. Can anyone think of a problem with this paradigm? You can just shout it out if you can think of something. Anybody? Sorry, what was that? You think it'll work? Okay, no problems. Anybody else? Yes, exactly. So one of the big problems with this is that you have to keep doing orchestration. You just have to keep running your model until your workflow is done. So it's pretty latency intensive, pretty costly. There's other issues with this. The model can just hallucinate, and now you've lost your polling mechanism. And so this team said, hey, we would love it if the protocol gave us hooks to implement essentially what we have done here. So that, again, got us thinking, and we kept talking to customers, and we talked to customers who were doing long-running test execution. Again, they were running into the same problem. They also implemented a workaround where they were calling their tool on pieces of the test execution output. So they could call it on the first piece and then say, okay, it's I still haven't seen the final log, so I'm gonna wait a little bit and call it on the next piece. But again, they ran into a bunch of challenges. We also met with a couple companies that were building deep research products, and same thing. They were having this problem that they just couldn't model deep research in synchronous tool calls, and they tried a bunch of things as well. So to summarize, I think one major problem is that we don't have a standard way of doing async, right? So all these kind of teams that are building workarounds, they're doing ad hoc stuff that requires client and server coordination, which is not great, right? It's not going to be generalizable. The other problem is a lot of these businesses are relying on the model for polling, and we kind of said like that's not ideal. It's costly and error prone. They're running into reliability challenges. So they keep that connection open for so long that sometimes it fails, right? And then they have a resiliency problem in their application. They run into scalability challenges because their servers now have so many connections open that they're actually not able to scale for the load they want to handle. And finally, they run into operational complexity. So in a lot of these cases, they have like a load balancer which is managing all these connections. And now they do a deployment, and now somehow they have to deal with the deployment draining of those thousands of connections, which all correspond to long-running asynchronous workflows. So it's not an ideal state. And that brings me to SEP 1391. So this is something that we have been working on at Amazon and also with the MCP community for introducing actual asynchronous tool calling semantics. This is something that we have, as a core maintainer group, have kind of committed to coming up with some approach for the next MCP release. And SEP 1391 is kind of where we're putting a lot of the thoughts about what this might look like. And the high-level concept on SEP 1391 is that we'll actually introduce a way to declare a tool as async. And when you call that tool, you'll get back a task token that corresponds to that asynchronous workflow. And then we're actually going to give you a new RPC method to fetch the status of that asynchronous task, and another RPC method to get the result when the status is terminal. So you'll actually be able to implement client-side logic to handle your asynchronous workflows without going back to the agent and doing other orchestrations. This is kind of what the change to the schema looks like. So you'll notice a new invocation mode field in the tool interface. And you'll also see that in the on the other side, when I show what a list tools looks like, you see this new invocation mode parameter. The default is still sync, by the way, so if you don't specify it, you still give a sync tool. Call tool request is also going to change a little bit. We're going to offer like a keep alive time, so you can say, hey, like I want this workflow to run, but if it runs more than 3 hours, it should die. And then in the call tool result, if you have an async workflow, you'll get this fancy token, which is your representation of this asynchronous task. Now, some folks may be asking, like, what is the difference between this token and a session? And after this talk, I'm happy to have a long discussion about like what is a session, which is an interesting topic in today's MCP, but it is different. And then we'll have this new RPC method. So this is what the status method looks like. It's just a simple, ask for a status with this token, and you get back one of these statuses and potentially an error message. And then you have an operation to actually get a final result. This is what it looks like when you actually write the code. So here I'm invoking a tool and I've passed my keep alive parameter. This is like I'm running like a large expensive analysis. I get back a call to a result. You can see that I'll pull on that result, which is this while loop. And if I get a completed status, then I actually fetch down the result and inject it back. So the code is still like relatively simple. And I could change the sleep to, if I know this is a very long-running workflow, I can like wait longer in between polls. So what are the benefits of this? One, you can use existing state management paradigms. So if you use step functions, if you use like some AWS batch or some other workflow manager, they already have semantics for this, right? They already have like task submission, they have status polling, they have result fetching. And so you can like exactly mimic what those underlying systems are doing now with MCP. You can preserve your native monitoring. So all the wiring you've done on your call tools, it stays the same because you're still doing a call tool request. So all of that instrumentation that you've already invested in can stay the same. We reduce some of the implementation overhead, right? Because you don't have to go and like implement some workaround for async. There's like a clear standard that we reflect in the SDKs that actually handle that paradigm for you. and it addresses some of the reliability and scalability challenges we talked about. One of the alternatives that we really thought a lot about was webhooks. Like, a lot of people really like webhooks, but one of the downsides with webhooks is it's like kind of annoying as a client to implement webhooks. Like, you actually need to maintain a URL where you can like receive all those results on. So that's like non-trivial, and we felt that it was premature to introduce webhooks. So this is sort of like forwards compatible with webhooks, the client polling paradigm, but it's just simpler and more common. So we kind of decided to stick with client polling for now. We still are like facing a few challenges. I don't know how many of you are like building MCP servers actively? Okay, and are you using elicitations? Anybody? Okay, one or two. So like elicitations is like an amazing feature. In fact, Amazon was, one of the folks from Amazon is the one who like proposed the specification for elicitations. But I think there are still some nuances in terms of how are you supposed to elicit, and when are you supposed to elicit, and do you need to start an SSE to elicit, and some of those nuances we're running into in the context of async. Because there's a whole bunch of cases where like an async workflow wants to elicit, and what is the right pattern for that? Should I, when I try to get a result, should I give you back like an SSE stream and then like pass you an elicitation on that? So that's a nuance that we're kind of trying to think through. Same with progress notifications. Like if I want progress notifications, what is the right way to get those from an asynchronous workflow? Because again, this sort of stateless paradigm that we have is not explicitly explaining what to do with progress notifications. And the final one is streaming. Like what if I'm running an agent behind that workflow and I want to stream you back tokens? Like how should that be handled? So these are three important questions that we're going to solve that are kind of part of what we're thinking about. And then finally, in terms of feature execution, feature extensions, I think one of the big ones is like task-based semantics. Like most of the six kind of, or 5 or 6 groups we talked to, they all want essentially tasks in MCP, and this extends to tasks, but figuring out how we actually represent those in MCP is kind of like an interesting open question. So I think the TLDR is we're investing heavily in client polling, right? We're excited about client polling. We want your feedback, so please take a look at SEP 1391. Please give comments as much as possible. We are gonna put out a sample implementation. So those of you who are like excited about async, you'll be able to try it out before it's actually in the spec and give all your grievances. So we can try to fix those things. So please do take advantage of that. And these are just some links. So link to SEP 1391, our Discord, and then at Amazon, we launched this cool thing called Agent Core, which is also like very much related to MCP. And so if you want to check that out, you can as well.